Okay, so I'm going to start today's class looking at some announcements because I sent a lot of announcements in the last few days. So I'm going to share my screen. Okay, can you see the announcements? Can everybody see the announcements?
Yeah.
Yeah.
Okay. All right. There's a bunch on here, so you want to make sure that you read them all, but some highlights. One, it says weekly help in statics. So if you open this up, you'll see these are all the folks that could help you with statics. You have my office hours, Rob's office hours. Andrew, our TA, is going to be doing an office hour from 10 to 11 right after your lab. So he's going to hang out for an hour. Karen Groppi has taught statics numerous times in the past. She has office hours. Paul Graham, a physics faculty, loves statics, but he may teach it to you a little bit different because, as you're noticing, physicists and engineers represent statics in a different way. And then once Carl's office hours are set and any other TAs in the STEM Center who I know are engineering majors who already took statics, I'll post theirs too. So there's a lot. Notice all our office hours are on the same link because we're all doing office hours through the STEM Center. So you only have to know one link. Okay. That was one thing I wanted to show you. Another thing I want to mention is I asked for those of you who get support through ASC, to let me know. So far, I only know of 3 students that have accommodations, and I don't think that's correct because typically I have 5 to 10. So if you're getting accommodations through ASCE, sorry, not ASCE, that's Civil Engineering Society, through ASC, you need to tell me, okay? Let me know.
Is it too late to register with the ASC or no? Okay.
No, I think you could. I mean, Cabrillo wants to help everybody, so you just go deal with it. Get it, and then let me know. Okay? All right, due dates. I've been getting a lot of people turning in things due, like things like, oh, I didn't see that there was a quiz. I'm gonna get stricter now because I don't want to have to be grading things later because anyway, I don't want to be doing that. So it says here, hang on a second. It says, if you know you will miss a quiz because of work or other, then tell me in advance and I'll have you take it earlier. Did everybody hear that? So if you know you're gonna miss something, then let me know in advance. And then I could have you but if there's no emergency, I'm not gonna have you do makeup. It's just too much. Important thing, keep your eye on the calendar. To say, oh, I didn't know there was a quiz is not okay. The calendar is very clear. If you click on the calendar, and I'll just click on the calendar, it shows all the due dates. So keep your eye on the calendar. Okay, or if you want to keep your eye on the due dates another way, you could do it. But for me, the calendar is the clearest. So make sure that you know when the due dates are. And the reason I'm doing this is just as you would tell your engineering boss that you have something going on and that you're going to miss a deadline or miss work, you need to tell me ahead of time too, not after the fact, of course, unless it's an emergency. I want you to be prepared to be a professional engineer. Okay, I'm going back to the announcements. So the first one is where you could get help in statics. The second announcement was about ASC accommodations. I need to know. The third one was about due dates. The fourth one is I'm posting the recordings. Everybody, you guys put on mute, please. Unless you're trying to talk to me. Okay. The third one is I am posting the video recordings from each class. And someone said they couldn't access one, so I wound up recopying it in a different way. But in any event, when you go to the modules, so let's say for last September 8th and 10th, that the module for that week, you notice there's a heading called class notes and activities. Then there's a heading that says Zoom recordings, and they're right here. And then there's a heading that says homeworks. Then there's a heading for online quizzes, and then a heading for in-class quizzes. Okay, so all the Zoom recordings are here. And then I've asked you if it was okay that I posted, and I'm still waiting to hear from 4 people, but I sent them a follow-up email. Okay, and then the last thing I made an announcement on, excuse me, was for where is it? Oh, here. Under along on new problems. Okay, but watch this video.
Joanne, you first.
Okay? I froze?
Yeah.
Okay, so about half of you got something wrong with this problem 63A. So I made a video of it. So you should watch the video. And then the problems that I saw, I will address as we do future problems as well. Okay? All right, I'm gonna stop sharing and just see, are there any questions? And I see the chat has a bunch in here. Okay, mic's not working, no problem. Paul is also awesome for physics, obviously for any of us in 4B. Paul is an awesome teacher. He is really an awesome teacher. No, you are cutting out a bit. Yes, freezing, yeah. Okay, could everybody see me? Am I okay right now?
Right now.
Not freezing?
It's
Okay,
still
I'm
freezing
closing.
a little bit, Joanne, as far as it's still not fixed. Like it's better right now, but yeah.
All right. Okay, I'm gonna get off my other laptop, close it. I'm shutting this down. Actually, I'm the only one on the internet right now because my husband and older son are gone, and my younger son is not, he doesn't have class till 10. So what I'll do too is I'm gonna close a bunch of these screens.
Run a speed test.
Okay, how is it seeming now?
Totally
see
fine.
how-
Better. That seems better.
Okay, we'll see how it goes. All right, okay, so I'm gonna go around the room like I usually do and asking questions. And I'm gonna go to OneNote now. So let me just open OneNote. Yep, it's already opened. Okay, so I'm gonna share my screen. Okay, so you guys could see the problem?
Yeah, that's good.
Okay, and now let me, I'm pulling off the keyboard. That's a major thing for me, not to be able to type.
We have separation.
I'm just writing. Okay, you're getting to see above my, hanging from my ceiling, I have a bunch of like glass balls that I blew
Oh.
and just like things I collected from trips. Let's see. Anyway, kind of arty. All right, so first thing is on Canvas, on this module, is the list, is the steps in solving statics problems. The first 3 parts are the setup, which you already know. What's the setup include? Adam, are you here?
Yes, I'm here.
What's the first thing you do when you're setting up a statics problem? What do you write?
You write what's given
Right, given and find,
and the
right?
find.
So
Yes.
first thing in the setup is given and find. Great. Amani, what's the next thing you do?
Do a table of the forces you have. And
Right,
the
and the table
direction.
helps you, right, with the magnitude and the direction, and it helps you find out what?
What you're missing and what you have.
Right, right. So in the end, you know how many unknowns you have, and when you know how many unknowns you have, then you know how many equations you need, and then how many free body diagrams you have to draw. Okay, and then Angel, I didn't see Angel yet. What's the third thing to do?
You should draw a free body diagram of your
Draw a
body.
free body diagram. Great. So we've already done a whole mess of problems. You've done 5, I think, for homework. We've done 4 in class. We've set up 9 problems already at least. And maybe you did some practice problems as well. And now we're going to continue to do that, but we're doing the whole problem. So not only are we doing the setup, we're also doing the solution. So here we go. Okay, given. Oh, wow. Okay, I can rest my hand on here. Okay, given. So we look at the picture, we have a cable here, we have a weight suspended. So Bon, what is the tension in this right here, in tension CD? What's that equal to?
I think that's the 1,000 pounds.
That's right, and you actually don't even just think it, you know it. You know that it is, because the weight goes right through this. The weight is here. Remember, this is my scrap. The weight is right here. The weight is suspended. It means the tension is carrying the weight. Okay? So we're not even going to think about that being a cable anymore. We just know that it's all the weight. Okay? So then we have a weight here. It's tied here with a pin, and then there's another cable here. So one thing you saw in problem 63A is that when you have a cable that's continuous, when it's one cable that's going around a pulley, the tension in the cable is the same. Did everybody hear that? When you have a continuous cable, rope, wire rope, cotton rope, if you have it going around a pulley, the tension is the same. And on Friday, Rob's going to spend time with you on pulleys. And also you're going to watch a pulley video from me and then do a pulley quiz that's due next week. Okay, so we have a weight here suspended. This is a different cable. And then there's what they're referring to as a strut. It's basically a bar, okay? And can a tension, Colin, can a cable take compression? Can I compress on a cable? Can it take a compressive load? Okay, Colin might not be here. Daniel C.
I am here, sorry.
Oh, you are here,
Not
Colin.
decompressed.
That's right. It could only take tension. But what do you think about this strut? It's a piece of metal. Can it take compression?
Yeah.
Yeah. A bar can take compression and it can take tension. So we could think about what it's experiencing right now, and we will in a little bit. But now we saw the picture. Now we read the words. So I first write sketch info. Then I read the words of 1,000 pound. Yep, there it is. You're right, Bon. 1,000 pound block supported by a strut and 2 cables is shown. So I'm going to say the weight is equal to 1,000 pounds. No more given. The find. Determine the forces exerted by the pin at C. So it wants to know what the force is here in the strut. And what's the 2 cables. So it wants to know TAC, TCD, and the strut. I'm just going to call it S. Do you want to call it SBC? We'll call it SBC.
That's good.
Okay, so a question that Jason had asked me is, what's the deal with the ACs and the CAs and the CDs and the DCs? You could call it whatever you want. Certainly it's nicer to say from one point to another point, from one point to another point. But look at this tension right here. If I'm analyzing this point, my tension goes from C to D. But if I'm analyzing this point, my tension goes from A to C. Sorry. Oh, look at that. I wrote C to A. If I'm analyzing this point, the tension goes from C to A. If I analyze this point, the tension goes from A to C. The magnitude of both TAC, the magnitude, and TCA are equal. They're the same. They're equal and opposite, right? They follow Newton's, what was it, third law?
That's good.
In any event, it's the same, right? So you don't have to worry about doing from and to. You could call it whatever you want. If you decide to use the two variables, TAC and TCA, you need to tell me that they're equal. But it doesn't matter to me because I know
Shit.
And Joanne, it looks like you're still having internet problems.
Dave, jump in.
Could it be like an internet problem or a hardware problem? Like, I'm thinking like, how much RAM is on the tablet? Maybe like the CPU on it.
Like it's having trouble with Zoom and OneNote.
Yeah, like.
Yeah, 'cause he hasn't had this problem before.
Oh, okay.
This is new, and so is OneNote.
Hmm. Oh boy.
No, that's no good.
Hey David, are you going to teach the
All
class?
right, somebody claim host.
David Lopez did.
David,
my
what are you gonna do?
All right.
I mean, I know just about as much as you guys
No,
about this
not
stuff.
you, David. The other David.
Like,
He's the
somebody-
host.
One of us
Oh,
actually
good. Oh,
claimed
good.
host. I logged on first this morning and gave me the option.
I wonder how it picks it. Is it just the first person to log in gets to be host?
You have to claim it.
I didn't do
Wow.
anything. I don't know. That's weird.
Like you go to manage participants, and it'll say claim host.
So other people, like Carlos uses a Surface, and maybe it's not OneNote though.
It might be a Wi-Fi issue.
I think it's most likely an internet issue because
Yeah.
Okay.
neither of those programs are very heavy.
What type of? What's that, Maria?
I got a text from Joanne. She said she's having internet trouble, but she'll be right back.
Okay, cool. What kind of test could she run to determine if it's a internet connectivity issue?
Closer to the router.
Say that again.
Unplug and replug the router.
Turn it off and on again.
Huh.
Solves everything.
Huh. What about a speed test? Would that reveal anything?
Yeah, I mean, if for internet, I mean, this seems like cutting out, not just super slow, but I mean, it's still, it wouldn't be a bad call at all.
Can you hear me now?
Yes.
Yeah.
Yes.
Okay.
Yeah, you're
So
back.
this is what I'm going to do. If this I'm just going to keep getting back on, but in the meantime, I want you to start solving the problem. You have the steps. If my internet craps out totally, I'm going to call Maria. And Maria, then put me on the speakerphone. Okay. All right. So let's go. Let's try this again. All right, so we have the weight, we know the magnitude and the direction. We have our strut. Actually, you know what might be a good idea is instead of, maybe what we could do, I'm gonna erase all this. How about we call it, how about we call it T1 and T2? That might be more comfortable for you. Oh, then I'm not dealing with TAC and CA. That might be a better thing. Okay.
Joanne, I have a question about the setup.
Yeah.
So, not specifically for this problem, but if they ask us to find like one specific force, but we have like two other missing forces, do we
Yes.
include those other missing forces in the find, or?
Excellent question. Excellent question. Because we haven't gotten there yet. You only include what they want you to find.
Okay.
In the find, you only put what you need. If they only wanted to know the strut, you only put the strut, the S in find. But in the table, you're going to have to put all the forces. But then when we go to solve the problem, we're only going to try to find the strut. And then we'll probably use another equation just to check it all. But that's great. We haven't gotten to that yet, Angel. Great for thinking ahead. Okay, the strut, we don't know the magnitude, but we do know that the strut is along here. It's either tension or compression. This is not a very good question mark here. Question mark, we know that. And then we have T1 and T2, and I put T2 here and we know it's the weight. And we know that, and T1 we don't know, but we do know its direction. So in the end, we're up to Daniel I. Daniel I, you here?
Yeah, hi.
Okay, how many unknowns do we have?
We have two.
Two unknowns. How many equations do I need?
Two equations, one body.
One body. And why do I only need one body?
Because you sum the forces in the x and then the sum of the forces in the y.
Right.
Equals 0.
Correct.
Both.
And thank you for adding the 0 at the end. That's important. It's an equation. Yes, and for a two-dimensional problem, we always have two equations, and we need two equations, so we only need one body. So the next question then is David L. So Leopold, what body do you want to analyze?
Point C. So it's the tip of the strut.
Right. And why do you want to analyze that problem, that point?
That point is kind of where you're focused in the wording of the problem. It says find the forces at C.
Great. And more importantly, it's where all the forces converge, right? All the forces come there, and we're still doing statics of particles, which means we're analyzing a particle. So we're going to pick all the forces. We're going to pick a point where all the forces come. This is T1. Oh, that's not looking so good.
Joanne, I had a question about that setup before we move on.
Yeah, okay.
Didn't you say we know the magnitude of T1 because it's the same cable?
Oh, okay, sorry about that. This cable is not the same. They're connected here.
Okay.
If there was a pulley here, and it was a continuous cable, T1 and T2 would be equal to each other.
Okay,
But
that's
it's
something
not.
it would
There's
say.
a pin.
It would say in the wording, right? It would say like frictionless ring or pulley or something. But
Yeah,
didn't
it would
that.
say that. In fact, I think it said pin, right?
I don't remember.
Yeah, pin at C.
Okay, yeah.
So it means we hear of a pin, you could think of a pin as like a screw or a nail. And we'll talk about connections as we move along.
Okay, thank you.
Okay, so David LR, what is this angle here between T1 and the vertical line?
25.
That's right. And the reason why is we're looking at this, right? And this line continues, and if This is 25, this is 25. Okay, so now we have to decide about the strut. So Edgar, and this is another issue that we had in the 63A problem. So I'm just going to draw, this is my free body diagram. So Edgar, looking at this free body diagram, you notice that T1 is up to the left.
Right.
And you notice the weight is down.
Correct.
Okay, so can you tell me from watching that video, if you watched it, can you tell me, is there something wrong with this free body diagram? Is there something missing?
Yeah, you have unbalanced forces because on the x direction, you just have one force, and that's not equal to 0.
Right, did everybody hear that? You guys, there is only one force going in the x direction, which means this is an imbalanced problem. It's not an equilibrium. This whole thing is flying somewhere if you leave it like this, or if you did statics analysis, T1 would be equal to 0 when you sum up the x, and then T1y of 0 does not equal 1,000. So there has to be another force. And in problem 63A, there was a normal force that the collar, it was a force between, there was a contact surface between the collar and the rod that created a normal force. So Edgar, looking at this, which way do you think S goes? Because we're not sure up here. It could take tension or compression. Which way do you think it goes?
I think it should go into compression. So it should go to the right.
To the right. So does everybody agree? Take a look at this. If T1 is going to the left, then you need a force that's going to the right. And S is the only one missing, so S goes up to the right. But we're not going to draw it that way. We're going to draw it the other way. And I'll tell you why in a minute. This is 60 degrees here, so this is 60. The reason why I'm drawing S the other way is because many, almost all the time, you don't know the direction that something's in. You don't know its direction. So in the end, I don't think you've ever had a problem like this in physics, maybe you did, but what happens, what kind of answer do you get if if a force was drawn in the wrong direction? Do you know,
Negative.
Elizabeth? Oh, okay, a negative. Jason, that's fine. So you would get a negative answer. And a negative answer is not bad. It's just telling you that when you look at the free body diagram and you look at the value of the force, if you have a negative answer, it just means the S is really going the other way. In this problem, it's not a complicated problem. We know for one, S has to go the other way because T1 is going to the left, the negative X. We have to have a positive X. But also looking at the picture, look at this picture. You have a cable leaning on a strut and a weight coming down. You know that strut is in compression and the strut has to be pushing up towards the cable, because if the strut wasn't there, the cable would just fall down vertical. But I want to leave it with the S going in the negative direction. So now I no longer have to look at my scrap work. I have everything I need here except for something. What's missing?
Axes.
Axis?
The axes, right. So what should we do it in?
Joanne, if we did put the S the other way, would that be okay?
Of course. Yeah, you could put the other S. Basically, okay, basically this is the rules. Have to be put in correct direction. Period.
I
Wait,
think.
wait.
Oh, sorry.
Oh, no. Is it about my writing or?
The angle 60. I think the angle 60 is inverted.
Oh. 60. No, if it's 60 here, it's 60 here, right?
Yeah.
Oh, that's okay. That's because of the question about which way you draw it. If you draw it up to the right, then you need to. Never mind. I got it.
then it would be on the vertical. Yeah,
Right.
David, definitely. You guys always stop me. Okay, so for our class, what do you always, up? I have to be careful I don't touch anything else. Always, 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 always. Weight. We always know weight goes down. Always. Tension, always drawn away. You would not draw T1 going the other direction. We know tension always gets drawn away. And normal, we know normal is perpendicular to the surface towards the body you're analyzing. And if it's going this way, you could draw it away over here, but you know the direction. So these you always know. You never put those in the wrong direction. But anything else, we typically don't even know. Okay? In this particular example, because there's not a lot of forces, we know the strut really goes the other way, but I'm going to put it this way just so that we see what happens if you put it in the wrong direction.
Oh, we can't tell because we're looking at her glass ornaments.
This is true.
Maybe
what if she would try like doing this on paper and seeing if that's the problem?
I think that's a good call.
I think that would be a good idea. Do you guys, is a lot better for you guys than on paper? How do you guys
No, paper was great.
No, paper's better, and the reason is I can see where her hand is. Things just kind of appear on this tablet, and it's like kind of hard to.
Yeah. Okay. I have Joanne on speaker. Can you guys hear her?
Can everybody hear me?
Yeah, that's okay.
Yeah.
Yeah.
Okay, but you can't visually see anything now.
No.
That's right. We don't see the OneNote anymore.
Joanne, we were talking, and we all decide, or a lot of us think that it might be better if we wanted to see if you just tried writing on paper and using the document camera and not using OneNote, because we think it might be OneNote slowing your computer down.
All right, let me try that.
Okay.
Okay, bye.
This is so funny.
So then, I just have a question to you guys. Like, when we're doing the sum of the forces, then are we always just going to use the direction angles, like how we learned how to use, like theta x, theta y, theta z? Do you think that's what's going to happen?
Well, I think it's going to be component wise.
Yeah, we'll have like sum of all x components and sum of all y components, and so it'll have a bunch of cosines, I think, because she'll want us to do it in like the.
We're going to use just the cosines, is I guess what I'm asking.
Yeah, because I think her philosophy is going to be the least amount of steps, right? So you're going to line them all up with magnitude, cosine, angle, and then sum those up, and it equals 0. And we're going to have 2 of those equations, what, for each body? Is that right?
Yeah. In 2D.
2 of those.
Yeah, that's it.
2 of those equations. No, it could be more than 2 equations for a single body.
Well, in 2D, it's got to be 2, right? Because there's sum of x's and sum of y's.
No.
Yeah.
You could have multiple. You could have more than 2 vectors on a single point.
Well, right. Okay. So in this one, there's 3, right? So the first equation will be x of the first one, x of the second one, x of the third one equals 0. That's one equation.
You can have you can have a ton of vectors, but you're only going to have 2 equations because you're only going to have the sum of the x components equals 0 and the sum of the y components equals 0.
I agree.
All right.
Yeah, at the very least, that's as far as we've gotten in the class so far.
Joanne.
Hey.
Hello.
Hello. All right, let's try this now. flipped, I believe.
We were theorizing that it might basically be the amount of energy or whatever processing power that one note requires
No,
is
that's
screwing.
ridiculous. So maybe it means I have to go to school to teach. Okay, so we have a free body diagram, right? We have the XY axis. Is that close enough? Should I zoom in?
No, that's good.
That looks fine. Yeah, that looks
Okay.
fine.
Okay, and then we have the forces on here. Let me look at the problem. My notes. Okay, so we have tension, what did I call it? Tension 1 or 2?
Wasn't that T1?
T1? Okay, and this is 25 degrees. And then we have the weight coming down, which is 1,000 pounds. And then we have the strut coming down.
Yeah, S.
Yeah, and what's this, 60?
60. Mm-hmm.
Okay. All right, I want to angle it because it's easier for me to write. But okay, so we did give and find. We did the table. We drew the free body diagram, and now we're up to the components part. Okay, so vector T1 is equal to T1 times the cosine of 90 plus 25, that's 115I, plus cosine of 25J pounds. So T1 is equal to, and I already did the math, so negative 0.4226 I plus 0.9063 J pounds, and that's what it's equal to. Okay? And then we have S, the vector S is equal to S times, so what is it? I'm going to go this way. So it's the cosine of 90 plus 60, 150 I, plus 180 minus 60 is cosine of 130 J pounds. And so S is equal to, could you just check me on this? This is a negative too. Good? Is that right? I could pull out my calculator, but let me just check. 150 cosine. Yep.
I think cosine of 130 might be wrong, Joanne.
Yeah. Is 130 right? No, it's
Cosine of 130.
It's supposed to be 120. Because it's 60, it's 180 minus 60, it's 120.
Then that is correct.
Good, great. Okay, so we have that, we have the components of T, and then I could do my checks. I could do my plus or minus visual check. I could do my force magnitude check. I could do my unit vector check. And then I do the same thing on this one, positive, negative check. And a couple of people mentioned in the homework that they were still not sure what the plus or negative visual check is, so let's do it. I'm seeing for T1 that I'm getting a negative X and a positive Y, and here's T1. Yeah, my Y is positive and my X is negative. And for S is negative in the X and the Y, and that's correct. And that's how I knew this was wrong here, because I looked at it quickly myself, okay? So I did the plus or minus visual check. There's nearly no force magnitude check because we don't have a force yet, but I could check my unit vector, 0.4226 squared, 0.9063 squared equals 1, and it does because I already checked it. 0.866 squared plus 0.5 squared equals 1, good. All right, so I did the components of T1 and I did the components of S1. And as I did them, I did the unit vector check for this, and I did a plus and minus visual check. There was no force magnitude check because I don't know what the forces are yet. Okay.
Sure,
And the
man.
last, yeah.
I'm still a little confused as to why that force S is not drawn as a compressive force.
Because I want to prove to you that it doesn't matter the direction that you draw S in. So we all agreed that S really should be going up to the right, but I'm drawing it in the wrong direction on purpose because there are many times in statics you don't know the direction of a force.
Okay.
And
So
when
we
you
actually
don't know the direction, you just assume a direction. So I made believe that I didn't know, and I assumed a direction, and now we're going to see what's going to happen with the answers.
Okay.
Good?
Yeah.
Okay. All right. And then we have our W, and we know our W is negative 1,000 J pounds. So now we did the components, and now we're doing the equilibrium equations. So sum of the forces in the X equal negative 0.4226 T1 minus 0.8660 S equals 0. Sum of the forces in the Y equals 0.9063 T1 minus 0.5. I'm just going to write the 5 minus 1,000.
Now you're off the page, Joanne.
Okay, great. There. Okay, I'm going to wait till you catch up on writing them because I want to talk about this. Okay, I'm going to wait until I see the eyes on me, and then I'm going to know everybody's finished writing it. Okay, is Eric here?
Yeah, I'm here.
Okay, Eric. How come these are called equilibrium equations?
Because the sum of the forces are going to equal 0.
Yep. This shows that it's an equilibrium equation. Many times what I see students write is this. Sum of the forces in the Y equals 0.9063 T1 minus 0.5 equals 1,000. Is this, Eric, an equilibrium equation?
No,
No, it's not. Why?
because the force is going to go in some direction.
Right, because the sum of the forces in order for it to be equilibrium, sum of the forces equals 0. This, you cannot write like this. What you can write, though, is you could say, from my equilibrium equations, I am finding that
You're off page.
Thank you. 9063 Ti minus 0.5 S equals 1,000. Does everybody see? What is the difference here? Here, I wrote the equation that came from the equilibrium equation. I did not say sum of the forces in the Y equals 1,000. Okay? Again, I don't want you to be sloppy. I want you to be professional and representing things completely true. The sum of the forces in the Y equals 0. But from this equation, you could get this. All right? So now, I'm going to pull my paper off of this.
Wait a minute. What was the difference between those two besides the 0.55?
What's the difference between these two?
Yeah, what is the difference between those two?
This one and this one. This one says sum of the forces in the Y equals 0.
Yeah.
And this one says sum of the forces in the Y equal 1,000, which is not right.
Okay.
Static, sum of the forces in the Y equals 0.
What about the one below it?
Well, this is correct.
You like
From
that
my
one?
equilibrium equation, I get this equation, and this is correct. The difference between this and this is I do not have some of the forces in the y in this equation.
Oh, okay. Yeah, I mean, I see the 0.55, but that's not what we're talking about.
I'm sorry, I saw, this is a 5s.
Oh, missed that. Uh-huh. Yeah, no, but that wasn't the problem you were pointing out.
Right,
The
I know,
problem
but
is
I just
when you
saw the,
have the sum of forces symbol or notation,
for statics, it's got to be equal to 0.
then it has to be equal to 0 or it's not statics. Okay.
Again, back in physics, you guys had to cover so much stuff that it was sloppy, and you were allowed to be sloppy because they wanted to make sure you knew the concept. But now the reason you take a full course on such a small piece of, we're now taking a full course on such a small piece of physics 4A, we're going to be detailed. So in the end, could everybody read what's under the highlight? These are my two equations that I got. This is equation 1, and this is equation 2. Everybody see that? Talk to me.
I mean, it's interesting what you did there. Like, you could have left it in the sum of notation, right, for equation 2.
I could have, but I want to bring a number over here because I'm going to show you matrices.
Oh, and you wanted to match up T1 and S.
Right.
I see.
I want
Okay.
to math words. I want to isolate the variables.
Mm-hmm.
I wanted to have all the variables on the left side, and I wanted to have the numerical values on the right.
Okay, that makes sense.
Okay, so first I want to finish the problem and then come back. So let's say I punch this into my calculator and I find out that T is equal to 869.1 pounds and S turns out to be a negative 424.2. Okay, now I want to talk about the meaning. Hang on a second. Your solution in statics. The solution in statics is the answers and the free body diagram. That's your answer. I'm up to Gerardo. The fact that I got a positive intention, what does it say about the direction I chose for T1? T1. I think he has to do it in the chat. I don't think he has a voice. Gerardo, are you still here? Okay, the question was, the fact that I got a positive T1, what does it say about the direction I drew T1 in the free body diagram? Okay, I'm going to go on. Hyoji?
Yes.
Are you here? The fact that I got a positive for the tension, what does it say about the direction I chose for T1 in the free body diagram? It looks like she froze too. Isaac?
That would mean, is this T1Y or T1X?
This
Just
is
general T1?
T1, because look, I know what the components are, right? 0.4226, right? So right now, this is only the magnitude.
Oh, okay, yeah.
If I needed to get the direction, I'd have to use the unit vector.
Yep.
But I found a magnitude of a positive T. What does it say about the direction I chose for T in the free body diagram?
It seems fine. I'm not sure if I fully
Correct.
understand the
The
question.
answer is it's
Yeah, it seems
correct.
fine.
Because I got a positive value for the magnitude of t, the direction I chose for t in the free body diagram is correct. So now, Jack, you here? Yeah. I got a negative for the magnitude of s. What does it say about the direction in my free body diagram for s?
I'm not sure, but shouldn't a magnitude be positive?
A magnitude should be positive except in a case like this. When you calculate a magnitude and you get a negative, it's telling you the direction is incorrect.
Okay. Yeah.
So the fact that I got a negative s, what does it tell you about this direction here?
Probably the wrong direction.
It should go the other way. Okay, so it seems like this is a little complicated for you guys.
But it's good.
So-
That's what we expected. We wanted us to go the
Okay.
other way because it was a compressive force.
Right. So we knew, in this particular case, we knew s was supposed to go up to the right. Okay, so the key here, is everybody listening? The key here is that many times in statics, you assume a direction of a force when you don't know what the direction is. And then if you get a negative, then you know the direction in your free body diagram is actually wrong. But you do not go back and change the direction of the free body diagram. Look, this and this are my answers. My answer is all of this. My answer is the numerical value, whether it's positive, negative, and the free body diagram. And this is what you would give your boss. Because what you're showing is T is positive, shown in that direction. S, shown in this direction, is negative. It means it goes the other way. This is our answer.
Joanne, would you correct it for your boss if you wanted to?
Nope.
Magnitude
You
positive.
say exactly like this.
Okay.
Because you have a negative here. It's not a bad thing. You got a negative, but the negative goes with this. Almost every statics problem, you don't know the direction of the force. We just happen to know it for this one.
So once
So
you,
that's
once
just showing that S is a compressive force, not a.
Correct.
Okay.
once
When
we
I
calculate-
draw a force away, we know when we draw a force away, it's tension. By getting a negative, we know it's a compressive force. Let me say that again. Whenever you draw forces away, it's a tension. We got a negative, so we know it's a compressive force. I really need to stop here because you're going to take your quiz in class right now on a setup quiz. So I'm going to stop here. But I urge you that it seems like this is kind of new for you. So I want you to watch the video again. Okay? I have to go to the modules. I want to see. I'm going to change the due date of the next homework. I'm going to change the due date of the next homework because we only got through one problem today. So on Thursday, we're going to do 2 more. Okay? But at least you understood the setup, the whole setup of the problem. I'm hoping that you'll watch the video so you understand the whole idea of the negative. And then I do want to show you how to solve matrices. And so on Thursday, we'll do matrices. We'll figure out how to solve for TNS a few different ways. And then we're going to do 2 other statics of particles problems. Okay, so I want to move on to our quiz now. Okay, so I'm going to stop the video. Thank you, David L, for showing me how to do it without having to unplug things.
Yeah, you're welcome.
Okay, so now I need to share the screen. David, were you going to say something?
You just said you're welcome.
Oh, okay. No, I saw you moving closer to the mouthpiece. Okay, so now I am in our module here, right? So here's the setup. Here are the class problems we're doing. If you want, you could jump ahead. Right here, there are 3 problems. We only did 1. Lecture notes. Oh, this is, I don't know what that is. Sorry, can't remember what I wrote. Oh, this is all, I'm in the wrong module. That's why. Yeah, I'm in last week's module. What am I doing? Okay, here. So here are the steps in solving the problems. Here are the 3 problems we're doing. And then I'll eventually show you the solutions to the 3D problem we're going to do. So you have a discussion post to do. You have a homework 7, which I'm going to change the due date. I'll probably just change it. But I want to give you the time to do. Here's the quiz, the in-class quiz. So I'm going to open it up, but you guys could open it up too. So let's see. Okay, could everybody see this on the screen or no? Probably not.
We see that, the particles quiz.
Yeah, you do? Okay, great. Okay, so it says 2 flower pots are supported with cables as shown in the figure.
My mistake. We
Oh
see a
yeah, we
different
can't see
window.
that.
Okay, all right. All right, so let me stop sharing and then reshare. Okay, you see it now?
Yes.
Okay. 2 flower pots are supported with cables as shown in the figure. So notice there's a link here and there's a link here. So these are not continuous cables. There's a cable here, there's a cable here, there's a cable here. And remember, the cable here we know is weight, so it's not an unknown. Same thing here. Pot A weighs 10 pounds, pot B weighs 8 pounds. Determine the tension in each of the cables and the slope of cable BC. So there is an unknown direction here. So what you want to do is just on a piece of paper, write your given, write your find, do the table, tell me how many unknowns are present, how many equations you need, how many bodies you need to analyze, and then draw the free body diagram. Okay? And it's open till I think 11:15 or 11:30. So you could stay after, and I will be here.
It won't let us start it because it's 10:29.
Okay, so you have to wait a minute.
Yeah.
Okay. And yeah, it's open till 11:30, so you have plenty of time. As soon as you finish it, submit it and move on. And I'll see you on Thursday. It should take you about 15 minutes max, but it may take you longer. Okay, I'll shut up now. Remember, this is just a setup problem. Given, find, table, equations, unknowns, and the free body diagram.
Would you like us to redraw the picture, Joanne?
You don't have to redraw the picture, but you do have to draw a free body diagram.